Alright, for question 1a, it's pretty straightforward. All you have to do is just divide by prime factors using this method, and then you should get the product of prime factors pretty easily. Now, part B is a little bit more interesting. Now, what do you do for part B is that you have to figure out what is 30 in terms of prime factors, which is 2 times 3 times 5, as I've done here. Now, the thing is, how do I find this number k such that 84k is a multiple of 30? All you have to do is to ensure that 84k has 2 times 3 times 5. At least this, and you can times any other thing. You can times 100 times a million. It doesn't matter what you multiply to this thing over here, as long as you have 2 times 3 times 5, then it is guaranteed that you will get a multiple of 30. So knowing this, what is lacking in 84? The numbers that you do not have in 84, you have to put in your k, such that 84 times k, you will get this 2 times 3 times 5 in it, okay? So it's pretty straightforward. I have a 2, I have a 3, so the answer is just 5. Right, so this is the answer. So 84k would be 2 squared times 3 times 5 times 7, okay? So it is a multiple of 30 because it has 2, 3 and 5 in it. So that's for the first question. Now we do the second one. Okay, so for this second question, the first part is very straightforward because it's just the standard procedure when you're finding HCF, right? You just divide by a common prime factor. So I've already done it, and the answer is this. Now for the second part to this question, is also a standard question, a little bit more difficult, but very standard. You need to multiply 616 with this particular number, such that the product of these two numbers, you get a square number. So basically, look at 616. It is 2 cubed times 7 times 11. It's just this HCF times the remainder. Now, to get a square number, you must have a power that is divisible by 2. So if you want to do a cubic number, the power must be divisible by 3. Okay? So let k be this number. I need 2 times 2, so that I will get 2 to the power of 4, correct? 616k would be 2 to the power of 4, okay? So now 7 is still odd, so I need to times 17. So 616k would be times 7 squared, right? Then I need to times 11 because 11 is also an odd power here. So like this, my 616k will have all even powers, such that if I want to square root it, so a square number means you can square root the number, right? So all you have to do is just take the powers divided by 2. So the square root of this number, which you don't need to find, I'm just doing something extra here, is this, right? So if I didn't have even powers, would I be able to come to this step? I wouldn't, okay? So this is how you do it. The third part to this question is a little interesting, because although they are looking for the same kind of thing, they phrased it a little bit differently, so don't be scared. All you have to do is just do the same thing, except that I need to find, let's use j, such that 560 times j will give me a cubic number. So remember I said for square numbers you have to have even powers, right? Powers that are divisible by 2. For cubic numbers you need to have powers divisible by 3. So I've already, expressed 560 as a product of prime factors here. Again, it's just the HCF times the remainder, which I've changed it into prime factors here. So divisible by 3. So 4 is obviously not divisible by 3, so I need to times 2 square. 6 is divisible by 3, right? Again, 5 is not, so 5 square, 7 square. Similarly, it's the same thing, right? I just need to make it divisible by 3. So this is my j. So I need to express this j in terms of a, b, and c. So a is simply 5 in this case, right? B would be 7 and C would be 2, because they stated is in this form, right? Okay, so this is how you do this question.